So in today's video we'll see how to make this. So I have a website over here and I have some circuits, and if I press on here, the LED will turn on, and if I press off, the LED will turn off. And yeah, I have not used any microcontroller, there is no Arduino involved. I have not used anything that is not available in your room, and this is everything. It's coded in Python, and you don't need to buy anything for this. You just need some wires and a transistor if you like. Okay, so let's see how that actually plays out. So what we're doing is we're not using any microcontroller, but we are using something that is built inside our computer. So if this is your laptop, then you know that there is an audio output port and there is a USB port. Okay, so what we're doing is we're using both of them to simulate a microcontroller. So this USB provides us with the power that we need to turn our LED, right? So this USB has 4 terminals. If you look inside a USB, you can see 4 terminals, and those 4 terminals, one of them is the power output, and another one is the ground, and 2 of them are data plus and data minus. Right, like you can see here, these are the 4 outputs of a standard USB. So the VCC will be the positive, ground will be the negative provided by the computer, and D plus and D minus are the data lines, which we don't need because the USB protocol is very difficult to understand, and we cannot do it unless we have some bigger instrument like a function generator and such. So we will not be needing these two. So the VCC is generally red in color and the ground is generally black in color, and if you have a USB lying around, you can just use that. Okay, so if you have a USB lying around, just cut the bottom part and use the red wire and the black wire, and I'm going to show you now how to do that. So this is the USB I was talking about, and I've separated the black and the red wires, the positive and the negative. I also had other wires, but I have cut them out. And for headphones, I am using this, which is a 2-way headphone jack. It has the same configuration in both sides, but if you don't have one of these and have these, which are earphones, you can also cut this part of the earphone and separate out the wires. Okay, you can Google it to see what kind of headphone this is and which color of the wire represents what. Okay, you can see that it also has 4 outputs. One is the left, or it's also called the channel 1 output, and the second one is the channel right output, and a common or ground and a microphone input. So we'll not be needing microphone input because we're not sending something to the computer, but we'll be needing left or right and a common is ground. So if you have an old headset, you can just cut it and open these 4 wires. You can check on the internet which color is which, and it is not same for everyone, every kind of headset, but it will be quite similar, and you can also find it in Google which one is which. But you can just use a 2-way headset if you have, and which I'm going to use. But if you have this kind of headphone, if you want to cut it, it's completely fine. So we're going to use left and common. You can also use right and common, it's up to you. Okay, you can use both. If you can connect both of these to one, and you can also use that also. So you can use left and ground, you can use right and ground, or you can connect left and right and connect these and make a single wire and use ground with it. It's completely safe. Okay, so since I want to show you first, I'm gonna assume that this function generator, this one, is our headphone output, and this power supply is our DC output. So if you have transistor, that will be really great, and I'm gonna show you. So you can use any NPN transistor. So assume that this function generator is our headphone output, and the positive is connected to the breadboard positive, the negative I've connected to the breadboard negative. The positive from this DC supply, which is the USB supply. Okay, just assume that this is the USB supply. It's connected to the positive of this side of the breadboard, and the negative is connected to the negative of this side of the breadboard. And I have an NPN transistor. Okay, so what happens is that we want to use this signal. We want to use the signal from the audio as a switch. So what I'm going to do is I'm going to connect the positive of this to the base of your transistor. Okay, since we want to use this as the switch, we have to connect that to the base. You can also use a resistor between these, but since the signal is already very faint, I don't want to make it less fainter, so I'm just going to connect directly. Now you need an LED. So the LED, the longer side, which is also called the anode, which is given by this curvy line, is connects to the positive, and this side, cathode, connects to the negative side. So what you can do is you can bring your emitter. So this will be your emitter, and what you have to do is you have to connect this emitter to the negative or the cathode of your LED. You have to connect the anode to the supply's positive. Okay, so now the LED is connected. The positive goes to the supply positive, the negative goes to the emitter, and this collector should be connected to the negative of the circuit. So your circuit is almost complete. You can also sort these negative. Since we are working with common collector configuration, you can sort these out. So now your circuit is almost complete. So now let's set up the parameter. The supply our laptop will provide us from the USB will be nearly equal to 5 volts or 4.5 volts. So in our function generator, I'm going to give an output of 3 volts and of 200 hertz and maybe a sine wave. So I've turned the DC offset to 0 because we don't need that. So you can set it to 2 volts or 3 volts as you like, but since we're just testing, I'm gonna use it or make it to 2 volts. So now let's run our simulation. So as you can see, our LED is turning on, and if we disconnect our signal from here, which I'm gonna show you right now. So I've disconnected the signal, and if I start it, nothing happens. Okay, so I need to provide a signal from here to make this LED turn on. So I have a very bad drawing, but this is the whole circuit. You can see that this is our signal, and the signal will be provided to the base of our transistor, and this will be the LED. This is the LED, and this is our USB output, and this is our collector, this is our emitter, this is our base, and the emitter is grounded. Okay, so this is the whole circuit that we're going to build. So now let's start building the circuit. So I've got my breadboard and my headphones. So this is a headphone jack. You can use an ordinary one. You can pull out the headphone part, but I have this, which would be much easier to use. I also have an LED. This is a red LED, and I also have a transistor. You can use any transistor you want, but this is this transistor. You can see the model number. I will also put it in the description. And let's get started. I also have this USB, and I have cut down its parts. So now I have a red wire and a black wire. So the red wire is the positive one, and the black wire is the ground. So what I want to do is I want to connect this on my breadboard. Okay, so the positive is the red wire, and it is connected to this pin over here. That's negative, that's positive, and the negative is connected to the negative, the black wire. So the next step will be to connect this is the ground of my microphone headphone jack. The big part is the ground, the larger area, and these two parts are the audio 1 and audio 2. And what I want to do is I want to connect I want to bring one wire from the ground one, and I'm going to bring one wire from one of these. So I can use any one of them, but I'm going to use the top one because it's farther away from the ground and it makes the contact even more nice. You can also bring wires from both of them. It's your choice. Okay, so it's done. So this is the ground one, this is the channel 1 one, and I want to connect this here and here. Okay, done. So this part of the breadboard will be the microphone positive and negative. This one is negative and this one is positive output, and this will be the 5 volts supplied from the USB jack. So this one goes to your computer, this one also goes to your computer. But now let's assemble the circuit here. So as I have already shown before, what I want to do is I want to use this output, this positive and negative output, as a switch to control the output from the USB. So for that I will need a transistor. So this is the BC547 transistor, and the rightmost part is the emitter and the leftmost part is the collector. So we'll have to assemble the circuit like that. So I brought one of the wire from the positive of the audio output to the base of transistor because that will be controlling our signal, and I'm gonna bring one of the wire like this from the positive of our supply, which will be from the USB, to the positive of our LED. Okay, so like this, the positive from the supply will go to the positive of our LED, and I've already done this base to the signal output connection. So the output from the audio, the positive, will be connected to the base, and the output from the USB will be connected to the positive of your LED, and the negative of the LED will be connected to the emitter. Okay, so like this, the negative will be connected to the emitter now, the positive will be connected from the USB, and the negative will be connected to the emitter. Now this collector will be connected to the ground, and since we are working with the common collector configuration, this ground and this ground, the negatives are to be sorted. And you can also not sort them, but if you want a higher voltage, then you should actually sort these two grounds. Yes, so we're connecting the collector to the negative of the supply. Okay, so I've connected the collector to this, from this wire to the negative of the supply. I've also sorted the negatives, and I've also shown this circuit elsewhere, so I think I don't need to explain much further for this. So this circuit will be now powered using this USB that we have connected here using these two wires, and the signal will be connected through this, and we're going to connect this to the headphones or the speaker out of your laptop or computer. Okay, so I brought my laptop here, and now I'm going to connect this USB to here and this headphone jack to its place. So if you're using Windows 10, then it might ask to validate if you have connected a headphone. You can just click on speaker out or headphone any way you like. You can click either one of them. I'm just gonna click on headphone and click on OK. So a great way to actually know if you have connected everything properly is to play a song on YouTube, play anything. And if the song, when the song plays, if you see your LED actually vibrating or LED flashing on and off, then it will hint that it is working. So I'm playing a song, and now the LED is turning on and off. So this happens because the laptop will send audio signals which will be amplified, and since the audio signal will be higher when the volume of the song will be higher, and it will be lower when the volume of the song will be higher. So yeah, certain songs will not trigger the LED and certain songs will. So now let's go to the coding part where we will code to send specific sound waves. Okay, so now if you're talking about code, then this is the whole code, and you don't need to know what this code does. You can just, I'm just gonna link GitHub below in the description. You can just go to the GitHub and download this x.py, and in x.py you have two functions. One is digital 1 and another one is digital 0. So you can call digital 1 to turn on your LED, and you can call digital 0 to turn off the LED. So keep in mind that when you run this command digital 1, then if you have connected nothing, it will output a very high sound from your speaker. So because since you are working with speakers and output and audio outputs, it will output a very high sound from your speaker. So always plug in your microphone, or so not your microphone, so always plug in your headphone before doing this. So what I've done here is I've created a simple Tkinter app with a button on and off. So when you press on, this command will execute, which is digital 1, and when you press off, digital 0 will execute. So let me run this and see whether this works or not. So okay, there you go, and this is the on and off, which I'm going to show later how this implements. But yeah, this is a simple Tkinter application for just creating two buttons with command digital 1 and digital 0. And I've also made a web application using Flask, okay, that gives a website where you can press on and off, and on will also call this function digital 1, and if you press off, this will call the function digital 0. Okay, so as for the app we have our on and off, and right now my LED is off, and if I press on, the LED will turn on, and similarly if I press off, the LED will turn off. Okay, so this works, and now let's test the web app. Okay, so I've made a website out of it, and now I wanted to show it from my computer, and it runs on my computer, but I wanted to show it from another phone that is connected to the same network, and you can also host this in the internet if you like. So if I press this on button over here, so if I press this, you can see that it's turned on, and if I press off, it will turn off. So on, off. Okay, so it's not just limited to with LEDs, but you can connect multiple items if you like, and you can also make use of the other channel to have two pins. Okay, so one could be your input, another one can be output. If you have a long jack where you have microphone in, also you can have three pins, one input and the rest of them have to be output. So I will teach you, or in another video we'll also see about other types of circuits that you can make using this. So I guess this is it, and if you like to see more or similar type of circuits, you can comment down below. And also I am planning to make further more different types of circuit using this same configuration, and if you like to see that, stay tuned. Goodbye.